How are you, everybody who is watching this video? My name is Olenjolai Moko TAYAI Losingo. My name is Olenjolai Moko TAYAI Losingo from beautiful country that's called United Republic of Tanzania. I'm very happy to welcome you today onto our online institution. And I'd like to welcome you onto our online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. Simultaneously, I would also like to welcome you in one of our official YouTube channel. We have 6 official YouTube channels. This is one of them. That's called the Online Diploma Polyinstitute of Tanzania in square bracket Olenjolai. Well, I will just spend a few minutes to remind you about a vision that we have in this in Online Diploma Polytechnic Institute of Tanzania. We have a vision. That's a vision that God has revealed in my mind. And also these visions I declared publicly, and I would like even God to help me to write also in the mind of all our students, so we'll be focused, because this is not entertainment institutions. This is not like maybe afterman institutions. This is a very serious and spiritual academic institution. So the vision that God has revealed to me is this. I would like to be a part of teachers or trainers or trainees, it means trainers, who are ready to prepare a special group of students, especially Tanzanians. Our primary focus right now is Tanzanians. Later on, we enlarge the tent, however, that we are not limited even right now, because through internet we can reach even other students from other countries. Okay, so I'd like to be a part of teachers who will prepare a special group of students who will be ready to take the classroom instructions in mathematics, plus engineering or plus science, because every engineer has a foundations of science, and also to combine with the spiritual knowledge of Word of God in order to solve real life problems. So the main objective of Online Diploma Polytechnic Institute of Tanzania is not just to teach students to pass the exams. However, that you might find that the contest will be putting higher percentage is to help the students in the academic performance. But the main objective is to change the mindset of the students and even challenge the students how they can take the classroom instructions in order to solve real life problem or problems. So our main objective is to see our continuing studying students, even if that will be a part of a large group of students who will be learning, will be studying at that time, who will be ready to challenge themselves and always start to think, what problems can I solve by the knowledge, the classroom instructions I have, combining with the knowledge of the Word of God in order to impact the community. So that is the primary, that is our main objective. So we know it's a process. It's not something that we build up within a single lecture or maybe within a single week. It's a process. But we believe that it's going to work, because even myself, what I'm using right now in solving this national problem is I'm using the combinations of the knowledge, skills, plus understanding, plus creativity, plus wisdom that I've gathered in the classroom, and then I combine with the wisdom of the Word of God. That's why now I'm capable to solve these real-life problems in training or in teaching students. We have some specific objective also in our online Diploma Polytechnic Institute of Tanzania. One of the specific objectives, we like to help all our students to pass very well and excellently their continuing assessment and even the final exam. So that's one of our specific objectives. Our second specific objective, to see that our students, they graduate successfully without wasting of time or without any kinds of absconding, any kinds of retake, unless there are some other reasons, but not academic reasons. So when you are, I believe that the viewer that is watching right now, this information makes sense to you. So in case that you are a diploma student, right, you are currently a diploma student, I would like just to tell you in advance that you are in the very right place. And believe me, at the end of the programs, you'll tell me that how these programs has impacted your life, because we've been changed in order to change the community, or in order to change others. Again, remember that basic engineering and scientific mathematics is universal. So these contents might be helpful to any ordinary diploma student. However, that our primary focus and the focus that will be focused, because it's better to have a primary focus. Our primary focus is by using the curriculum and the syllabus of United Republic of Tanzania, which has been published or has been accredited by the National Council for Technical Education. In abbreviations, we call it NATE. Right? However, the contents, because for example, today I'm going to teach you about factorial function. Factorial function is universal. Even in Brazil, students there, they're learning factorial functions. Even in the United States of America, they're learning factorial function. In South Africa, they're learning factorial function. United Kingdom, they're learning factorial function. So this is a universal concept. So these contents might be useful elsewhere in any institution, in any college, in any ordinary diploma college, right? They will be useful, even for the mathematicians who love mathematics. This content will be worthy for them. Okay, so let us go now to the business. Okay, I'd like to welcome you. We have some departments, but one of the departments is called Basic Engineering and Scientific Mathematics. Our aim here is we want to train and want to prepare the best technicians. So if you want to be the best technician, stay tuned. Okay. So we said that we are in departments of engineering, basic engineering and scientific mathematics. And then we have the first topic is the first main topic, which is called the fundamental rule of counting, or the fundamental rule of counting. And I would like to do the quick review. The subtopic, because we say we have how many subtopics for fundamental rule of counting? You still remember it? Stop, pause the video, and then write down all the 6 subtopics of fundamental rule of counting. So then we are in factorial functions, and then this is lecture 2. It's titled as problems solving. So we'll be solving different problems related to factorial function. Again, we insist you to review. Okay, we insist you to review. It means that we insist you before you continue this session. You can stop, and even you have to review first lecture 00, which is titled as the general introduction. So 40. General Introduction, Basic Engineering and Scientific Mathematics for ordinary diploma, NTA level 4 to NTA level 6, or from first year to the first year to the 3rd year, right? So review that, and also review this lecture 01. Okay. Again, if you go through lecture 00, we have explained briefly what is visions of this institution, what is mission, what problems are we solving, how are we going to solve. So we have provided many information that I touched a little bit when I was beginning my session. So I didn't want to go into too much details because I did that business. And you can access these 2 videos and even all other videos in our YouTube channels that are called online Diploma POLYINSTIT. This is abbreviation of these 2 words, of Fort of Tanzania, Olenjolai. So you can search in YouTube, and then you will get it. Then you have to subscribe, because we are going to upload more than 100 videos of basic engineering and scientific mathematics until level 4 to NTA level 6. So it means that it will be worth it for you if you subscribe, because the YouTube community will give you the official notification once you upload a new video. Okay, so in lecture 01, first of all, we say that we have subtopics. I present to you. We have main topics, okay? Main topics of what? Because the course or the modules is called the fundamental rule of counting, matrices, differentiation. So there are 3 main topics: fundamental rule of counting, matrices, and the 3rd main topic is differentiation. Then we began with certain fundamental rule of counting. Here I say that there are 6 certain subtopics. I won't mention, review that lecture because it's still there. And that's the beauty of digital platform compared to the analog. Again, we defined what the meaning means, that the definitions of what? Definition of factorial function. So because this is the cornerstone of the previous sessions and even today's session, we say, factorial function. What is factorial function in mathematics? In mathematics, factorial function is a product of all positive numbers. So we say that factorial function, which you notate like this one, we said is a product, or let's say factorial function is what? Is a product. Product of what? Product of all positive, what? Positive, all positive integers. So positive integers in maths, we write them like this one, all positive integers, right? All positive integers less than or equal to the given positive integers. Less than or equal to the given positive integer. So we'll be given a positive integer, and then so if we find factorial, we find is equal or less than to the positive integer. I gave you two definitions, so make sure that you watch that sessions to know the second definitions, how you really define. But mathematically, because why am I doing a quick review? This is the techniques that God has given me in order to incubate or in order to teach or in order to teach. It means that the main objective of quick review is to link the previous lecture to the current or present or to the present or current to a current lecture. So it means I'm trying to link what I'm doing here. I'm linking the lecture 1 with lecture 2 so that my lectures will be in sequential order, will be linked together. Okay, so don't get disappointed because this is a technique that God has given me and I've used it for more than 11 years. And according to my research, it has been working for thousands of the students. They have been liking. Even if that I start, sometimes let me just give a testimony. Even if that I start teaching there, and then my students used to tell me, "Sir, you forgot to give us a quick review." Okay, so in mathematics, you say that factorial function, we have this, suppose n is what? This n is a positive integer, right? Suppose that n is the element of 40 of the positive integer. So we use exclamation mark to have notations of the factorial function. So this we read it n factorial. So n factorial, for instance, this will be what? N, and then you open bracket n minus 1, then you multiply by n minus 2, then multiply by n minus 3, then multiply by what? N minus 4, multiply by what? N minus 5, multiply by what? N minus 6, and then if you get that, you just put factorial. Also, I gave you some special factorial. So if one in mathematics, if you have 0 factorial, the answer is 1. Also, if you have 1 factorial, the answer is what? Is 1. So we need this special 2 factorial function in every perspective. Well, so we solved the 2 examples, but again, before we ended the session, if you do remember, I told you that how you can use your scientific calculator, for example, FX 991, okay, Casio FX 991, to find what? To find the factorial function of the certain number, for example, 5 factorial. So I told you, you write the number, it means that you inject the number, which is 5, and then you press alpha, and then you press a button which has x power -1, and here it is a factorial sign. So in case you want to get too much details, go to lecture 1. So let us go to our today's business. So problem solving of factorial function. So in this lecture, we are going to focus on the 2 parts of who, because we said that in previous lecture, which you said that in lecture 1, right? We evaluated it. Okay, we evaluated the value of factorial function, FCT function of 40 of positive integers, of different positive integers. For example, we can find that we get is 5, when the value of 5 factorial. Okay, 5 factorial. So you do remember that 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 5 times 4, so the answer is what? 5 times 4, 20. Times 3, 60. Times 2, 120. So that's what you've been dealing, and even by using scientific calculator. So we say that in this lecture, okay, so we are going to solve problems. Okay, problems. Excuse me, my voice is not still okay, but don't worry, it will adjust itself. problems related to what? Related to factorial function, okay, in two other aspects. And these are very important. Remember that also insisted that factorial is the prerequisite of the next subtopic called the permutation. And factorial is the prerequisite for the next third subtopic, which is called the combination. And factorial also is a prerequisite for the fifth subtopic, which is called the binomial series. Binomial expansion. Factorial function also is a prerequisite of the last subtopic in fundamental rule of counting. That's what we call the binomial series. So you have to understand it, because we're going to sing this song until we finish this main topic of fundamental rule of counting. So in the other two aspects, what are these aspects? So I'm going to teach you problem solving in first simplification. So simplifications of 40, simplifications of expression, right? Expressions. So simplifications of expressions of 40 of factorial function, right? So we'll be dealing with letters now. So it's a kind of, I can call it, myself, I can call it like a algebra for factorial function. Okay, then the second part or second aspect that it will be solving, right? Solving factorial equation, right? Finding the value, just like in algebra. So these are the two main parts that we are going to focus. So let us start with the first one, simplification. When you say simplification, it's not a new vocabulary to you in mathematics, because you had a simplification of algebraic expression. So it's a simplification of expression of 40 of factorial. I've been teaching factorial for more than 5 years, but I thought, how am I teaching today is quite different from what I used to teach them or my other students. So it means there's added value of factorial function. For example, in previous years, I was not even classifying and writing the subtitle. I was just writing the question there and then we solve. Students used to say that we understood, but they find, yes, they understood, but they don't know the secrets. Okay? That's very important to learning something. Okay, so simplifications of expressions of a factorial function. So we solved the two examples and I left the homework. Hopefully, I believe you did it. So make sure that you submit it through the comment section. So let us begin with the simple questions and then we'll come later to the challenging question. So example 3. So let us start with simple. So the question says simplify this expression n factorial over n plus 1 factorial. So this is the rational factorial function. It's a rational factorial function. Yes, so n factorial over n plus 1 factorial function. So in case of simplification, this is the technique you have to remember. In case of simplifications of algebraic expressions or factorial function, we have to write that expressions into the simplest form by using different. If, for example, it is a rational function, there's a relationship between numerator factorial function and denominator factorial function. If it is just a linear factorial function, it means that it does not contain the denominator, it's a linear, right? So under that perspective, there are some common terms that you have to take them out. So we'll see those examples. So you have mainly those two perspectives, and don't worry, I will be showing you and you will notice every part of it. So solution. So when we be asked mathematics that simplify, you mean that, okay, this is one of the expressions, but it's not simplified. So it's not in a simplistic form. So you have to put in simplistic form. Okay? So simplify n factorial over n plus 1 factorial. So the first step that you have to do as my beloved student, we say that check if the numerator okay, the numerator, okay, because for the numerator and denominator is either a subset, numerator or denominator, okay, is a subset, or check if the numerator is either a subset of 40 of denominator. That are first checked. Okay, so listen carefully. What does it mean? It means that a factorial function can be this the shorthand factorial function. Remember that. Not this one. Not this. So this is n factorial. This is called the shorthand of writing what? Of writing factorial function. While that ones I can also write like this one, n minus 1 times n minus 2 times n minus 3. Then if you get this one, so this is long, or this is we call it, yes, it's a series of 40 of factorial function. Okay, so so where is numerator? This is numerator. So our numerator for that problem, we say that our numerator is equal to n factorial. So n factorial. So let us try to expand if we find that it's a subset. So if you expand n factorial, this is equal to what? According to the rule of factorial function, it means that it will be products of all positive integers less than. So n, and here we have n minus 1, then we have n minus 2, possibly we put. So in these three terms, 1, 2, first, second, third, can you find any terms which is likely to the denominator? No. So it means that if it's not, the n factorial is not a subset of 40. Okay? So it's not a subset of denominator. When I say subset, remember in terms of in the course of the set. So if, for example, you have a certain set, right? When you say subset, this is the mathematical language. So is it a part? If you expand, what does it mean? If you expand numerator, can you find the last term, or maybe we can find one of the terms is n plus 1 factorial? That's the meaning of that sentence. So from this one, it means that n factorial is not in a subset. This is the way a subset of 40 of n plus 1 factorial. Don't get confused about those terms, not subset. If you forgot terms, don't worry. But you can take time to understand what does it mean. Okay. So then the second step, if that is just failing, the second step, you say that check, right? If what? Denominator. So denominator is what? Is a subset. Is a subset. It's a subset of 40 of denominator. Of numerator. You just want to be sure, but you know that if numerator is not a subset of denominator, then denominator is a subset of numerator. That's how the principle works. So let us take denominator n plus 1 factorial of that given expression. If you expand this, it will be n plus 1, then multiplied by n plus 1 minus 1, and then we multiply by n plus 1 minus 2, then you get your third, you stop there. So this expression is equal to n plus 1 times what? N plus 1 minus 1 is 0. Then we say that we have n minus what? 1 factorial. So you see that n plus n here. We say that, okay, n plus 1, n. So it means that, okay, n is the one of the term of numerator. So in this situation, we can say that, okay, we can end in the only second term because the second term is similar to the numerator. So you can say n plus 1 and then n plus 1 minus 1. Here it was just a test, but now I've noticed the factorial. So then n plus 1, then we say that n plus 1 minus 1, this is n factorial. So n factorial will cancel with that n factorial numerator. Right? So if that's the case, you say that, okay, fine. So to have expression of n factorial over n plus 1 factorial, right? factorial. This is equal to what? Don't. So this is n what? N plus 1 factorial. So n plus 1 factorial is a subset of what? Of n factorial. So if the subset of n factorial, then you got the steady state. Listen carefully. You have to enjoy the beauty of factorial function. Okay? So you got the steady state now, which is the last state, the steady state, right? Steady state. The steady state, we say that now expand what? Numerator, no denominator, which is the subset of 40 of the denominator. So expand numerator, factorial function. Okay? How do we expand? Simple. Okay? And so expand denominator factorial function, but don't expand what? The numerator. So we will be given n factorial over n plus 1 factorial. This is equal to what? Don't touch this. Leave it. So it is n factorial. Then in this part, just expand it to have two terms. The first one will be n plus 1. The second one will be n plus 1 minus 1 factorial. Right? So if this is the case, here we have n factorial, and then here we have n plus 1 minus 1, that is n factorial. So this one and this one will cancel. So simply you find that n factorial over n plus 1 factorial, this is equal to what? So in the numerator we have 1, but denominator we have n plus 1. And this is the last simplest form of that expression. Okay? If you have any question, don't hesitate to ask in the comment section. Okay, so let us go now to the example 4. So example 4, this is in case you have what? You have, okay, let me give you more example. Okay, so the question states as simplify what? Simplify this expression, which is n factorial over n plus 1 factorial plus, you enjoy the beauty of mathematics, n plus 1 plus what? n plus 1 factorial of what? n plus 2 factorial. So this is the expression that we have to simplify. Do you enjoy the beauty of mathematics? Tell me in the comment section. Again, tell me in the comment section that you are receiving this material from which institution, from which country, from which region. Tell me in the comment sections, because I'll be so glad to know that really this message now it is spreading the entire nation, okay, of the Republic of Tanzania. Solution. So this question has two parts. The first part, it's the one that we have dealt together. The second part, this is the new one, but also you can inspect, you can do even by inspection, right? So we say that the solution, we say the first step, which we have to say, or which you have to deal with, is we say that the first step, because it has two terms which have been added together. First step, we say that simplify what? Simplify n factorial, the first term, over n plus 1 factorial separate. So how do we do that? So I told you inspecting which term between numerator and denominator is a subset of the other. It means if you expand, we find the other terms. If you expand this one, we'll be having, the next term will be n minus 1 factorial. While if you expand this one, the next term will be n plus 1 minus 1, which is n factorial. So n factorial and n factorial is a close relationship. And even we solved in the previous example. So n plus 1, so don't expand the numerator. So leave the numerator terms as n factorial. The denominator, we have n, right? N, then we say what plus 1, and then we have what n plus 1, and we say minus what? Minus 1 factorial. So it is the case, n factorial, and then here we have n plus 1, and n plus 1 minus 1 is n factorial. So n factorial cancel. So after simplification, it remains 1 over n plus 1. That's the first system. Okay? Do you enjoy the beauty of mathematics? Ask your neighbor if you are learning at the group this content or this material. Okay? Then we say that we go now to the second step. Tell your neighbor, you love basic engineering mathematics? Do you love basic scientific mathematics? Okay, so we say that now let us simplify the second part, right? What is the second part? The second part is n plus 1 factorial of what? N plus 2 factorial. Wow. So to simplify again, we say inspecting. Okay, now we can do by inspection because you know, inspective, we say, we can say even something that the longest term, or we say that it means inspective, the expand, the term which can be expanded. So you can say that one's expanded, which can be expanded. So if you expand this one, the next term will be n factorial. And the next term will be n minus 1 factorial, for instance. So if you expand in 3 terms, it will be n plus 1 times n minus 1 factorial, which none of those 3 terms is similar to n plus 2 factorial. So the numerator is not a subset of the denominator. So you cannot expand the numerator. If you inspect the denominator, if you expand this denominator by even 2 terms, it is enough. So the first term will be n plus 1 times what? N plus 2 minus 1, which is n plus 1 factorial. So the second term of denominator, which is n plus 1 factorial, is what? Is the term that we have in numerator. So they will cancel. So factorial functions of denominator and numerator will cancel. So it means that if you inspect this one, you have to expand what? N plus 2 factorial. Always, whenever that you find the terms which is containing the largest integer, is the one that has to expand, whether the terms is in numerator or in denominator or in numerator. So for that case, you say that to have n plus 1 factorial divided by what? N plus 2 factorial. So we expand the denominator, because that's how we can simplify this function easily with fact. So if you expand it, it will be n plus 2, right? And then it will be n plus 2 minus 1, which is n plus 1 factorial. So you cancel factorial function. So if you cancel factorial function, it means n plus 1 factorial over n plus 2 factorial. This now is equal to what? The remaining term, which is 1 plus n, 1 over n plus what? Plus 2, right? So, if that the case, we had what? N factorial over n plus 1 factorial, we plus what? Plus n plus 1 factorial over n plus 2 factorial. This now is equal to what? For the first term, after simplification, we've got 1 over n plus 1. Second term, after simplification, we've got 1 over n plus 2. This again is not a simplistic form. What does it mean? It means we can simplify further, right? We can simplify further. How can you simplify further? So it is one. So you say we have 1 n plus 1 plus what? 1 n plus 2. So with this one, you can find the denominator. So if you find the denominator, it is what? N plus 1 times what? N plus 2. Okay? So we take this expression, we divide by this term. Then we get what? N plus 2 times 1. The answer is n plus 2, this one, plus. Then take this over this term. It means n plus 1 times n plus 2. So we divide by this term. Then we get n plus 1 times 1. So it is n plus 1, like this way. Right? So then, once we simplify, we have, you can expand even the terms in the denominator. That n times n is equal to n squared. N times 2 is equal to 2n. 1 times n, it is n. 1 times 2, it is what it is 2. Then in numerator, you can also open the bracket and add the like terms. N plus n is 2n. 2 plus 1 is 3. So then here we have what? 2n plus 3 divided by what? N squared plus 3 what is 3n plus what? Plus 2. So therefore, we say that we have what? We have n, we have now n factorial over n plus 1 factorial. Then the big gives n plus 1 factorial over n plus 2 factorial. After simplification, the answer is what? 2n plus 3 divided by what? N squared plus 3n plus 2. At the simplified form. Okay? So this is the simplified form. Okay, so now you have the clear understanding in case the function which is being given is in rational form. It means that it's a fractional form, right? So now we have again another form. So now go for example 5. And this example 5 is very interesting. Okay? Very interesting example. Do you enjoy the beautiful basic engineering mathematics? Do you enjoy the beauty of basic engineering and scientific mathematics? If you do, tell me in the comment section so that I may be happy with you. So we have again another expression. This is refer our tutorial sheet of DIT and even some other institution. And this tutorial question 3. Okay, tutorial question 3. So the question says that simplify. So if you have your tutorial listing, you check this question, you might find it is one of the tutorial sheet over n minus 2 factorial. Okay, so that the questions. N plus 1 factorial over n minus 2 factorial. I think that this is the simplest one because you have just to, it's a kind of the trick. Yes, let this be your homework. This is your homework too. Because the next example, which is example 6, is a little bit challenging more than this. So this is simple because you have numerator, denominator. So I told you the principle behind. Okay? So I believe that you'll do it and submit your homework in the comment section of this video. Not of another video, this video. Example 6. This now it is concept now. So now we are getting into the challenging stuff. It's a concept because there is the concept which you have to deal with. Simplify, the question said that simplify n factorial over n minus 1 factorial and r factorial plus r factorial plus n factorial numerator of what? N minus r or plus r. N minus r plus 1 factorial. And then r minus 1 factorial. You can pause this video. Don't don't be frightened or shamed by the concept, by a phrase or by the word concept. So n minus r plus 1 factorial and r minus 1 factorial. So you can pause the video, right? So you can stop it for a moment and then you can try. Do that. Stop the video. It's simple. That question is very simple if you have understood what have been the previous two examples, and also if you did this example before this. Because the question is simplified, meaning that you do all your best to write it in its simplest form. Okay. So you can pause the video and then try yourself on the piece of paper. Afterward, then you check the solutions of how I have solved it, so you can correct it yourself, the mistake that you've done. The best way of learning, on my side, is learning through doing mistakes. I don't like to do mistakes, but it happens that I can do mistakes. But I'm not confused by doing mistakes. I'm very confused by doing mistakes without learning. So it means that 80% of what I'm teaching you is the outcome of mistakes I did myself when I was at this level. And another thing which I'd like to remind you, remember that Olenjolai does not know everything concerning factorial function. I just know a small portion of factorial function, just know the small portion of basic engineering and scientific mathematics, but I'm ready to teach everybody what I know. So that is who I am. Solution. So we've been given such expression. Again, we have to still using the principles like I told you, that you have to inspect the given expression. And this given expression has two parts. So numerators, there is no problems. We have the same numerators in both terms, first terms and second term. And again, we have denominators which they look like they are closely related. So we say that solution, as we said, so it means that we have to check a numerator which is a subset of the other, right? So I say that, so by inspection, if you expand this one, the next term after this will be n minus 2 factorial. So it means that this one is not a subset of this term because there's a close relationship between this term and this term. There's a close relationship between this factorial function, this factorial function. If you expand this, the next term will be n minus r. And the next terms will be n minus r minus 1 factorial. So n minus r minus 1 is this n minus 1 or n minus r? N minus r. Thank you very much. It's n minus r. So the next term of n minus r, it is n minus r minus 1 factorial. While the next term here, it is n minus r factorial, which is closely related to this one. So we say the first system, we say that check by using inspection. By inspection, the related what? The related factorial function. Related factorial function. Related factorial function. What does it mean? For numerators, there's no problem. For denominator, you find that n minus r factorial function, this is closely related to n minus r plus 1 factorial. Also, if you examine there, we have what? R minus 1 factorial. This is closely related with r factorial. Right? These are the two different terms, but they are closely related. What does it mean? relate, so you can find the relationship. Okay? So if this is the case, now what do we say as mathematicians? So you have to examine which is the subset of the other. If you expand this, so you should not just worry. You just use your hand and your mind to think. Okay, it means to help to analyze your thinking. N minus r, the next term for this case will be n minus r minus 1 factorial. Right, for this term, the first term will be, if you expand, n minus r plus 1, this is our first term. The next term will be n minus r plus 1 minus 1 factorial. See? So it means that n minus r for this second part, or second denominator, then have n minus r, 1 minus 1 to 0, what factorial. So you see that when we expand this factorial function, we get part of this function. You see, in the first order, in the denominator of the first fraction. So this is meaningful in mathematics. Again, we say that r minus 1 factorial is closely related to r factorial. That is good, right? So if you're closely related, you have to think which is the subset of the other. If you keep, for example, if you expand this one to the next second term, first term to be n minus 1 or r minus 1, and the next term will be r minus 1 minus 1, which is minus 2. At what? Factorial. So when we expand this term, r, first one terms will be r, next one will be r minus 1 factorial. So there's a close relationship between r minus 1 factorial and r minus 1 factorial. So we have to expand this in order to get this term. This side we have to expand this in order to get this term. Then we are done. We just follow some simple algebraic concepts of simplification. Okay. So if this is the case now, we say that we go for the second step. Okay, so the second step we say that let us expand first term. Expand the denominator of the first term. And we should not expand every part of that denominator. So once we have n, so for instance we have n factorial, and hence the denominator with n minus r factorial, and we say that we should not touch this, we have to leave the way it is, but there we have r factorial. Next term will be r minus 1 factorial. Okay? So remember that this one is equal to n factorial of what? N minus r factorial, r factorial. Still, they are still equal functions. Okay? So expand the of the first step. So then the third step, we say that let us expand what? As expand denominator of the second term. Of the second term, right? Of the second term. So we say that we have n minus r plus 1, n minus r plus 1 factorial. No, so let us write the whole term. Okay? So we have what? So we have n and n factorial, while denominator we have n minus r plus 1 factorial, and then say what? R minus 1 factorial. So don't touch the numerator, just deal with the denominator. And this is already expanded because you have it here after expansion. Remember, this is equal to this, this is equal to this. So you have to expand this You have just to expand to get on the two terms. So you have n factorial in numerator. In denominator, we have what? N minus r plus 1, first term. The second term is n minus r plus 1 minus r, but what? Factorial. And then so you have r minus 1 factorial, which we didn't touch it. Okay? So it means that now we can write that given expression in that form. So if you write in that form, our first term now be n factorial over n minus r factorial, then times r minus 1 factorial. Then this one we say that plus what? N factorial. Don't touch it because it's common. In denominator, what do you have? Our denominator now, it is changed. It is n minus r plus 1. Then you have what? N minus r factorial. And then save r minus 1 factorial. Okay? So if you examine this one, this is common factorial function, common factorial function. And again, this is common with this. And then this is common with this. So you can take all the factorial function outside and have in a bracket in between. So I've been teaching simplifications of expressions of factorial function. So these are the expressions. We don't have equal sign. That's why we call them expressions. The first step, we say that now take out all factorial function. So take out all factorial function. How? As I said, n factorial is common. So we take n factorial outside of the bracket. Then say what? Denominator. R minus 1 factorial is common to R minus 1 factorial. So we just take it out. R minus 1 factorial. Okay? Then n minus r factorial is the same with n minus r factorial. So again, in the denominator we take n minus r factorial. I think you see where we're going. N minus r factorial. So if that's the case, okay. So if that's the case, we have taken how many factorial functions do you have here? 2, 1, 2. And with numerator 3. So 3, 1, 2, 3. So we have 6. And then for this case, we open bracket. For this term, we remain with 1 in numerator divided by what? R. Because this is taken out, and even this we have taken out of the bracket. So plus what? So once we took this one, we remain with 1 over n minus r plus 1. Okay, 1 plus r. That is. Okay. The next step now, we have to simplify those terms that they are have r n minus r plus 1. Okay. So take out all the factorial functions. So the next step, because now we don't have any factorial function, the next step now we say that you have to add this term and this term, just numerically. So we have n factorial, we are simplifying, telling your neighbor we are still simplifying the same example. Right? So then we say that this side you have r n minus r plus 1. So take this term divided by r. So 1 times this. So n minus r plus 1. Take this term over this term, we get r. R times 1 is what? It's r. Then close the bracket. So add the like terms. So if you add the like terms, r and r will cancel. So the remaining is what? N factorial outside of the bracket of what? N minus r factorial. Then n minus r factorial. Then you have this. So it will be n plus 1 divided by r. And then you say what? R, then you have n minus r plus 1. Okay? So that is. So here again, it is not the simplest form. It's one of the simple form, but not the simplest form. Again, if you reach at this stage, we say that the first stage. Okay? So in order to finish our simplification, we say that expression above in only factorial function. Only what a factorial function. What does it mean? So once in the numerator we have n factorial times n plus 1. That's what we have. What do we get? What meaning? Or how we can write this function simple and we still have the same function. So the simplest way that we can write is n plus 1 factorial 1, because if we expand this n plus 1 will be the first term and the next term will be n factorial. Right? Do you understand what am I teaching you? Do you understand really? Tell me in the comment section, please. Okay. So tell your neighbor we are still solving one example. Okay. So then we say that the n factorial and that ones. So let us check again. There's a close relationship between n minus r factorial and r minus n and n minus r plus 1. So you can put, because they are multiplied, so you can put them together and see what is going to happen. N minus r factorial, and then here we have n minus r plus 1. Is it n minus r plus 1? Yes, but no factorial value. N minus r plus 1. Then we have to think differently. How can we write this factorial function without losing its meaning? Okay, this is the way. So you can pause the video and think, should you write either n minus r factorial or should you write something else? So if you inspect it, so by this is by inspecting, if you write this function as n minus r plus 1 factorial, then these are the same function. Because the first term will be n minus, if you expand this function, n minus r plus 1, which is this one. The second term will be n minus r factorial, which is this one. Right? So in other words, you say that n minus r plus 1 factorial, this will give us what? N minus r plus 1 times what? Times n minus r. That's the meaning. So even this term, this term here. So you can interchange. Yes, you can say n plus 1 factorial. This is equal to n plus 1, hence n factorial. So again, we have another term. There's a close relationship between r, here it is n minus r factorial. I think that here there is a little confusion. I did a mistake here. Excuse me, correct this. Here we had the r minus 1 factorial. And here we had n minus r factorial. So here we have n minus r factorial. So this one is not n minus r factorial. This is r. So I thank God who have opened my eyes to see this mistake. R minus 1. And similarly here, this is what? R minus 1 factorial. So there's a close relationship between r minus 1 factorial and the r. So you can take them as a product. N minus r, no, r minus 1 factorial, we multiply with r factorial. R minus 1 factorial, we multiply with r. R does not have factorial. So how can you express this function by using the single term? Single factorial function, not a multiple like this. So in this term, if you examine, this is similar if you say I have r factorial. Why? Because if you expand this r factorial, the first term will be r, the second term will be r minus 1 factorial, which is this. So they are multiples. So for that case now, we say that r factorial, this is equal to what? Is equal to r times what? R minus 1 factorial. So suppose that this is equation 1. And also we have another term, which is this one. Okay, which is this one. This is equation 2. The one that we've simplified here. And then we have the third, because we have the third function. Okay. The third function will be this form or in this form. I think the simplest one is this one. So this is equation 2, equation 3. Then this one will be equation 4. So the next step now, which will be the sixth step, we say that substitute equation 1, equation 2, equation 3, and equation 4. Equation 4, you know what in equation 1. So if that's the case now, we would like to say that we have what? So like to say that having n factorial of what? Over r minus 1 factorial, then we have what? Then we have n minus r factorial. This is equal to what? Minus r factorial. And then we have what? In bracket, we had what? We had n plus 1 of what? Over r, n minus r plus 1. This is an example, so you can find a question. There are 6 marks. So we'll be gathering many marks if you be simplifying this. So now we say this is equal to n factorial. N factorial now, the part of n factorial times this, we formed is n plus what? 1. So this is n plus 1 factorial. If you expand this, we get the numerator. Again, we say that we divided by what? So here we are. So you have r minus 1 factorial times r. So that is equation 4. So equation 4, instead of writing that in redundance while the function can be expanded, is r factorial. Right? It's r factorial. So then we go for it. Next term. Right? Next term, what the next term? So the next term now we say we have n minus r factorial, n minus r plus 1 factorial. So our answer means that this is n minus r plus 1 factorial, right? So it means that that just simplified. So all of this expression is just equal to this expression. So you cannot simplify further to that point at the last response. And you have to congratulate yourself for being patient with this problem. So therefore, we say that you'll be given a function that was saying n factorial, and then denominator we have n minus r factorial, then you have r factorial, this plus what? Plus n factorial, n minus r plus 1 factorial, okay, n minus r plus 1 factorial, r minus 1 factorial. So this one, after simplification, is equal to what? N plus 1 factorial, and then denominator with r factorial is again what? N minus r plus 1 factorial. Okay, so that is the n, and this is the last equation. Is the last response. Okay? So that's the simplest form. I believe that you have learned so many concepts in dealing with that problem. Again, I told you that we can simplify a factorial function, an expressions of factorial function. Also, we can solve, right, factorial functions equations. But the third thing which I want to add to you is we can factorize, say factorize. Remember, algebraic expressions can be factorized. So even this factorial function can be what? Factorized. So this is the example 7, possibly. It's 7 or 8. Because we need example 3, 4, 5. Okay, possible that is example 7. So example 7, the question showed that factorize will be given two expression. The first one, it is like the one that we need, n plus 1 factorial, then plus n plus 2 factorial. The second one, it is n minus 1 factorial plus n plus 1. N minus 1 factorial plus n plus 1 factorial. N plus 1 factorial. Yes, n plus 1 factorial. So you have two problems. This is the simplest one. Let me leave at the homework for you. So we say solution. So I'm about to finish this session for this lecture 2. So we have solution, right? So we should want to factorize this Roman 2. So the first step, right? So the first step, we say that inspecting each term. Inspecting which term is a subset. Is a subset of the other. What does it mean? If you expand this n minus 1, the next term will be n minus 2 factorial. Let me write. If you expand n minus 1, the next second term will be what? Will be n minus 2 factorial, right? So if this is the case, we say that, so if you expand the next term will be n minus 2. So this is not a subset of this expression because regardless of how long we are going to expand it, we will never get this term. We will never get any part of the terms which is common. So then we say that we find n plus 1, those largest expressions, largest divided expressions. This is the subset of n minus 1 factorial. How? If you expand this one, it will be the first term n plus 1. The second term will be n plus 1 minus 1. The third term is n plus 1 minus 2, which is n minus 1 factorial. So if you write clearly, this is equal to n plus 1. And then there we have what? N. And then we have n minus 1 factorial. So n minus 1 factorial is common with n minus 1 factorial. So we just deal with this, we don't touch this. Okay, so I'm about to finish. Make sure that you do the homework, make sure that you subscribe, make sure that you read descriptions of this video so you can get further information, links for our other official YouTube channel, but also you can get the method which in case you feel from your heart you want to offer God your free will in thanksgiving in order to participate on the running course for this program so that hundreds of the videos of basic engineering and scientific mathematics should be in air for the present and future generations. So you can send your free will in thanksgiving to God through these programs or through me, who is chief executive of this program. Okay? Through this telephone number 0759 74 53 31. If you want to also do the bank transactions, read the descriptions there at the account and the bank number. Okay? So for that case that we say n minus 1 factorial plus n plus 1 factorial. This, I told you that don't touch n minus 1 factorial, leave the way it is. Then we plus with n plus 1, right? And then we say that here n plus 1 minus 1, then you have n plus 1 minus 2 factorial. So if that's the case, you say that this is n minus 1 factorial plus what? N plus 1. And then n plus 1 minus 1 is n. And n plus 1 minus 2, this is n minus 1 factorial. So if you examine, if you inspect it, this term is common with this term. So because you want to factorize, we call it a common term, so we take it out. So n minus 1 factorial, right? And then once we take n minus 1 factorial, in this term we remain with 1, right? In this term we remain with what? We remain with n plus 1 times what? Times n. You can also keep on simplifying because I told you how to simplify to the simplest form. That you can even never simplify it further. So you can expand there, n times n is n squared, n times 1 is n. So that is a simple, it is the factor of that expression. So therefore we say that n minus 1 factorial plus what? N plus 1 factorial. After we expand, we find that is what? N minus 1 factorial. And then you have n squared plus n, which is quadratic expression like this. So this there. That's the response. Okay, so this is the end of this session. I thank God who have been with me in the preparations of these sessions and even during the teaching. And I thank God who have given me you who is watching this video. I really love you so much. And I want to teach you in different ways. And believe me that you are going to change your way of thinking. You'll be thinking like a leader who wants to solve problems in real life, not in class, not in exams. You'll be solving exams, but you are mostly focused is to solve real life problems. So may God bless you abundantly. Thank you very much for watching and thank you very much for asking questions, for participating actively. Make sure that you share these contents with your classmates. basic technicians, ordinary diploma students, first year, second year, third year, they should not now suffer in mathematics because the solutions is in their hands. It's not limited. You can take these sessions during the day or during the night. And God has asked me to do this great business and offer this free willing thanksgivings of mine, of gift of teaching, and even that all the means all the multimedia equipments and every kinds of the running cost, the transmission for the internet and electricity and whatever. I'm the one who also paying for that. So it's all of them are my free willing thanksgivings to God, so the Tanzanian present and future generations. So even yourself, if you want to connect your face, you're warmly welcome, and your finance or your offering will be used effectively in paying the running cost for this program. I will never even eat a single shilling. And God has told me to offer it free for this content for almost a year. I have agreed that, and I believe that it's going to touch the life of different students. So I'm still waiting and making a conversation with him that what after 1 year. However, these contents will be there for the rest of our life. So may God bless you. Let us meet in lecture 3 when I'll be teaching you how we can solve factorial or equations of factorial function. Very important. It has been asked in different exams, so don't miss it. May God bless you. Let us meet inside of lecture 3 of problem solving of factorial function, but our main focus into what we want to concentrate on simplifications. We are done in the evaluation, so we have to go further as well as we can, but we'll be focusing on solving equations of factorial function. May God bless you. I love you so much.